Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with a new topic, coordinate bond. Now coordinate bond is a special type of covalent bond where the electrons which are shared in the electron pair, they are contributed by only one of the two atoms which are participating in the bonding. So one of the two atoms is only giving both the electrons, that is the electron pair. It is also called a dative bond. We also refer it as a dative bond. Now we have to look into the conditions which are required for this bond formation. Now the atom which is going to give the electron pair, that atom should be having a complete octet, and also it should have a pair of valence electrons so that it can contribute this pair. And the acceptor atom, the one which will accept, should be short of a pair of electrons, then only it can gain the electron pair. This type of bond is represented by an arrow. So here you see the arrowhead is pointing towards B, so B is receiving the electron pair when the coordinate bond will be formed, and A is the donor. So A is the donor atom, B is the receiving one, so it is the acceptor. So we can represent it in the form of A and B, generalized form of representation. You see, if A is an atom, you can see A is having complete octet. All the 8 electrons are there in its valence shell, and so it can give one pair. This pair it can be giving because it is octet is complete. And you can see here B is short of a pair of electrons, so it can be the receptor, it can accept it, it can be the acceptor. So here you see in this condition, here the shared pair has been given by A only and B is sharing with A, but both the electrons here are being given by A only. B is not contributing any electron in this shared pair. We can have a look at some examples. Like you see ammonia NH3, when nitrogen forms 3 single covalent bonds with hydrogen, ammonia is formed. Nitrogen has a lone pair. This lone pair over nitrogen can be donated. So this can be the donor. Whereas BF3, boron trifluoride, boron is short of electrons. Boron octet is not complete even after bond formation with 3 fluorine atoms. So even if BF3 has been formed, covalent bond, it has formed a molecule, still it is not having complete octet. It is short of electrons. So nitrogen can donate one pair to boron of the boron trifluoride molecule, and here you can see one coordinate bond has been formed between ammonia and BF3. Next example we come across is in hydrogen peroxide H2O2. Now see, you know water molecule, water is a bent molecule. Oxygen in water molecule has a lone pair of electrons over it, and it has formed 2 single covalent bonds with 2 hydrogen atoms. This lone pair over oxygen can be donated during the formation of coordinate bond with another oxygen atom. This arrow shows that one lone pair has been donated from the oxygen of water molecule to the other oxygen atom, thus forming a coordinate bond between them. So H2O2 hydrogen peroxide formation takes place in this way. Now if you go to the characteristics of the coordinate bonds, that is the compounds having coordinate bond, we find that they exist in all the 3 states, solid, liquid and gas, in normal conditions. The melting and boiling points of these compounds are little higher than that of covalent compounds. Covalent compounds are by sharing of electrons, where both the atoms contribute equally in electron sharing. But the melting and boiling points are definitely lower than that of ionic compounds. In ionic compounds, there will be a electrostatic force of attraction between the ions, which are formed by donating electron and by gaining electron. The atom which donates the electron forms cation like sodium, potassium, and the atom which gains the electron like chlorine, they form anion like chloride. Then there will be electrostatic force of attraction. So such ionic compounds, which we have discussed in earlier video, you can refer to that video, they will be having higher melting and boiling points. So coordinate bonds have melting and boiling points intermediate of that of covalent and the ionic compounds. Now you come to solubility. These compounds which have coordinate bond, they are sparingly soluble in polar solvents like water. Water is a polar solvent, but they are readily soluble in non-polar solvents, which are mostly organic solvents. Organic solvents are non-polar, so they dissolve in non-polar solvents. They are very stable like covalent compounds. This is because of the strong bond they have. They are paired electrons. The bond formed is strong bond and it cannot be separated easily. This gives rise to the stability. They are bad conductors of electricity. This is in resemblance with those of the covalent compounds. They also exhibit molecular reactions, but these reactions are slow. They exhibit rigid bond. The bond formation is rigid and also directional. Therefore, they exhibit the property of isomerism. Coordinate compounds show isomerism. They have very high values of dielectric constant. Now, we can just try to explain the bond formation. Like we have just seen that in the coordinate bond formation, the shared electron pair is given only by one atom and the other atom is the acceptor atom. So now how to explain the bond formation? Here the donor atom gives one electron to the acceptor atom. So whenever any atom gives electron, it develops a positive charge. And when the acceptor atom, any atom which receives the electron, it will develop a negative charge. So we can explain the positive charge over donor atom and negative charge over acceptor atom. This can be explained in the diagram. You see here A is the donor. So it has given the electron to B. So A became positive. B has accepted the electron, accepted, so it has become negative. Now these are now charged particles. After this charge formation has taken place, now these charged particles can contribute one electron each. Now they will contribute one electron each and this can be shared by both. So this A can give one, it will not give, it will share, and B is also, it has already taken one electron from A, so this electron only will be shared. So actually when sharing has taken place, these are the electrons which are shared. You can see from the colored dots that actually they both belong to A. B has not contributed any electron in this sharing. Both the electrons have come from A. So now we can say that between this A plus and B minus, which is just a representation of the two atoms, the bond formation has taken place. And since both the electrons are donated by the same atom A, it is a coordinate bond, also called as dative bond. I hope you have understood the concept which I tried to explain today. Thanks for watching the video. Please subscribe to my channel. Thanks for watching. Thank you.